Hello everyone, welcome to the series of the USCS Coding Challenge application video walkthrough. In this channel, you are going to see how Anika Vital team prepares, designs, and implements a system with application and infrastructure components and pack the solution to meet the customer's requirement. In the previous sessions, we have covered the system design, development, and deployment. Today, we will take a look at the security and compliance considerations. I wish it does not only explain how our team completes the task, but also give you an idea on how to choose the appropriate technologies to meet your customer's requirement. For today's session, I divide the content into 3 parts. We'll start with how to protect backend APIs with Okta. After that, we'll look at static code and third-party tools analysis using SonarQube. We will end this session by performing image and secret scanning with Trivy. Okay, let's get started with API protection. It is very common to perform authentication and authorization check in the application's front end. In USCS Coding Challenge, we enforce authentication in the backend as well. Using Okta for your API has significant benefits over traditional API key mechanism. Enhanced security. Okta issues short-lived access tokens. These tokens are less prone to misuse compared to long-lived API keys. You can define specific scopes for API access, such as read or write, to limit what a client or user can do with the API. Tokens have a limited lifespan and can be revoked, reducing the risk of unauthorized access if credentials are compromised. User identity integration. Okta ties API access to user identities, enabling features like RBAC, which stands for Role-Based Access Control, and integration with SSO, which stands for Single Sign-On. You can also enforce multi-factor authentication, MFA, for additional security. Standard-based solutions. Okta supports OAuth 2.0 and OIDC, which are industry standards for secure API access. Centralized access management. Okta serves as a central point for managing API clients, permissions, and user roles. You can integrate with other apps and services in your organizations for seamless identity management. Audit and complaints. Okta provides detailed logging and monitoring capabilities. Before introducing Okta in backend API authentication, we had an idea to use traditional API key. However, after analyzing the system requirement, we decided to choose Okta. In most cases, API keys are mainly for simple, low-risk scenarios, such as accessing public data. If you do not need user-specific access control, or you prioritize simplicity over the security and manageability, API keys will be a good choice. On the other hand, if your APIs handle sensitive data or require user-specific access, you want to enforce modern security practices and comply with industry standards, and you need to manage access across multiple APIs and applications consistently, as our USS coding challenge does, you'd better pick up Okta. Now we understand that we want to choose Okta in our scenario. Let's see how Okta works with the application. The client application, which is a web frontend in our case, requests a token from Okta. Okta will issue a token and send the client request along with the token to the backend API. Then the API will validate the token, either through the application code or the proxy service such as Amazon API Gateway. If it is valid, API will respond to the client's request. To create an API service in Okta, log into the Okta admin console. Navigate to Applications, click Create App Integration. Select OIDC OpenID Connect and Service for the application type. Fill out the application details, including name, for example, my API service. Sign in redirect URLs. It is not needed for a service app. And click Save. To configure the scopes and permissions, go to the API Authorization Servers section. Select the default authorization server or create a custom one. Under the Scopes tab, add scopes that represent the permissions your API requires. For example, read data or write data. Under the Access Policies tab, define policies to control which users, groups, or clients can access your API. Now it is a time to write some codes to use Okta issued access tokens to secure our API. First of all, we need to add Okta's Spring Boot starter to your project. After that, we will configure Okta in application.yaml. Then we can protect API endpoints by using Spring Security to ensure only requests with valid tokens are allowed. We also need a security configuration class. Finally, we will generate and validate tokens. If you are using AWS API Gateway, you can configure it to validate Okta-issued tokens. Alternatively, you can offload validation to a middleware or backend service. Now we have a solution for API authentication. Let's take a look at static code and third-party tools analysis by SonarQube. It ensures the source code and the dependencies to build the application package meet the security requirement. SonarQube is a popular static code analysis tool that helps developers identify bugs, vulnerabilities, and code smells in their projects. It integrates seamlessly into various stages of the software development lifecycle. Version control systems. SonarQube pulls code from repositories like GitHub, GitLab, Bitbucket, or Azure DevOps. CI/CD pipelines. SonarQube integrates with Jenkins, GitHub Actions, GitLab CI/CD, and some others to run scans as part of the build process. Here is an example of running SonarQube from a Jenkins pipeline using official Maven Docker image. The analysis happens in several steps. Project setup. We define the project in SonarQube, specifying the key details like programming languages used and build tools. You can also configure rules and quality gates to suit your project's needs. Source code scanning. The code is scanned using Sonar Scanner, a command line tool, or through plugins for build system like Maven, Gradle, or Ant. During the scan, SonarQube applies static code analysis to examine source code without executing it. Custom rule sets to include default and custom rules for best practices, vulnerabilities, and performance. Third-party tools may integrate tools like PMD, FindBugs, or ESLint. Metric collection. SonarQube collects metrics across different dimensions. Code quality. Identifying issues like unused variables or inefficient loops. Code security. Defects, vulnerabilities such as SQL injection or cross-site scripting. Maintainability. Flags code smells that could make maintenance harder. Test coverage measures the percentage of code covered by unit tests, which requires integration with testing frameworks. The results are sent to the SonarQube server, where they are aggregated and displayed in a detailed interactive dashboard. Key features include issue categorization, which includes bugs, vulnerabilities, and code smells, are classified by severity, including blocker, critical, major, or minor. Drill down capability, which allows to view issues at the file, method, or line level. Trends and history, which allows to track project quality over time. Quality gates, which is used to define thresholds that determine whether a build can proceed based on code quality. SonarQube fosters continuous improvement by highlighting new issues introduced in the latest code changes, encouraging developers to maintain high standards by enforcing quality gates, integrating with developer tools to provide inline feedback during coding. SonarQube supports over 25 programming languages, including Java, Python, JavaScript, TypeScript, C#, Go, and more. It also provides tailored rules and checks for each language. SonarQube can be deployed in two main ways. The self-managed, which is referring to an installation on your server, either on-prem or cloud, giving complete control. Or SaaS, which is a hosted version called Sonar Cloud for convenience and scalability. In addition to the static code analysis, we also run the Docker image and secret scanning against the application package built from the CI pipeline. We use a popular open source vulnerability and security scanner called Trivy. It is known for its simplicity and comprehensive scanning capabilities. It can scan container images, file systems, Git repositories, Kubernetes clusters, and more for vulnerabilities and misconfigurations. Additionally, Trivy has a capacity to detect secrets accidentally stored in your codebase. Trivy identifies vulnerabilities in container images, including operating systems packages and application dependencies. It ensures that the images used in your production or CI/CD pipelines are free from known vulnerabilities. Trivy identifies issues in application dependencies such as Python, Ruby, Node.js, Java. It also provides CVE details, severity levels, and remediation suggestions. Trivy pulls the Docker images and scans it layer by layer. It checks against the common vulnerability and exposure, the CVE database, and other vulnerability sources like the NVD, Red Hat, and Debian security advisors. Here is an example of running Trivy from a Jenkins pipeline using official Trivy Docker image. Please also pay attention to the volume mapping, and the generated scan result as a JSON file will be stored there. Besides image scan, Trivy also checks secrets. It detects sensitive information such as API keys, passwords, tokens, and private keys accidentally committed to repositories, container images, or file systems. It searches for secrets in all file types, including .env files, YAML configuration files, and source code. It also identifies both hard-coded secrets and those exposed due to misconfigurations. Trivy uses predefined patterns to identify potential secrets in files. It also takes the code repository as parameters. Here is an example of running Trivy from a Jenkins pipeline using official Trivy Docker image. Please also pay attention to the volume mapping, and the generated scan result as a JSON file will be stored there. When using Trivy in your project, try to follow the best practice. Automate image and secret scanning in your Jenkins, GitHub Actions, or other CI/CD workflows. Continuously scan container images and repositories, especially after updates. Define custom patterns for secret scanning to align with your organization's specific use cases. Use Trivy's output to prioritize fixes based on severity. Regularly rebuild and scan images after addressing vulnerabilities. That is all about the security and compliance in USCIS Coding Challenge. I hope you learned how do we meet security and compliance requirements today. Thanks for watching and see you in the next video.